before I start this problem, I want you guys to figure out or take a guess, what is your u going to be? Okay, it seems to be the hardest part for students when they're first starting this out. What is your u for number 881? And the trick is, or what I like to think about, which works like 80% of the time, is what is the most inside function? That's what I like to make u equal. And sometimes whatever you pick, sometimes it doesn't work. You have to go back and pick something else. I'm gonna pick 1 plus x to the third. Now I do this a certain way, guys, and I know there's other ways to do it. There might be a faster / easier way for you to do it. And if you know that way, that's great. Okay, I'm going to show the way that I have found has been the easiest to teach students. Okay, so the first thing you got to do is you got to find your du. Our goal right now is to get all the x's out and then put the u in. Okay, because our goal is to try to simplify the way this thing looks a little bit so that we can do the antiderivative. So I want all the x's out. And so that means this x and this x, they got to be gone. And this dx, don't want him anymore either. All right, he has to be a du, and I want these to be u's. So the first thing I'm going to do is I'm going to take the derivative. And I'm going to take the derivative with respect to x. So that is implicit differentiation. What is the derivative of u? It is 1. And then you would have a du dx. Correct? Everybody with me? Yeah. And then the other side, derivative of a constant is 0. Derivative of x to the third is 3x squared. And that's it. So I took the derivative of it. Next, what you're going to do is you're going to rewrite this, which is the advantage of Leibniz notation. It almost looks like that you're multiplying both sides by dx. So it says du equals 3x squared dx. So it looks like I multiply both sides by dx. Next, I try to see if I can start simplifying things. Okay? Not simplifying, sorry, substituting. All right, so let's do our u sub now. So I have my elongated s right here, the integral sign. We have x squared over u raised to the second power. That was the easiest thing to switch out so far. You don't have to write that line. I'm just taking it very, very slow. And now I see right here an x squared and a dx, which is good news because right here I see an x squared and a dx. What I don't see up here is a 3. So there's other ways to do this, but the way I like to do it is like, okay, so I want to get rid of this 3 right here so that I have an x squared dx so it looks just like this. Kind of like this one, I got something that looked just like this, and I put a u in there for it. I took out the 1 plus x to the third power. So over here, I'm going to multiply both sides by 1/3. That's the same as dividing by 3. I would write 1/3 du, and this side would just have x squared dx. And so I have an exact match. There's my x squared dx. Look, x squared dx. Wow. Okay, so I could take this x squared out and like kind of just put them in front of the dx, and there'd be a 1 up there, right? Because you could do that with fractions. So now I could write it like this. I can say 1 over u squared, and then I put du. Du, because that's what we're subbing in for this. But wait, what am I forgetting? The 1/3. You can put the 1/3 right there, and then actually it would go down there with the u. But 1/3 is what we like to call a scalar. You can take him out. Whenever you guys anti-derive or when you derive, you can take scalars out and work with them later. And so I'm just going to put the 1/3 out in front, and when I'm done with my business here, I will multiply the 1/3 out to everything. Okay? So this is how I think. U to the negative 2. Du, and then I'm doing my antiderivative of this. I'm going to add 1 and then divide by, I guess that would just be a negative 1, right? Right. Okay, so I have 1/3 times negative u raised to the negative 1 plus c. That's what I get when I do my antiderivative. We can simplify it a little bit. We can put this u on the bottom so we don't have a negative exponent. I'm going to multiply out the 1/3, so I get 1 over 3u, right, because this guy goes on the bottom, and it's negative, because it's a negative 1 that we're multiplying to, and then we have plus c. I'm not going to multiply 1/3 to c because the c is an arbitrary constant. He just changes into something else that's a constant, and that is the end of the integration. But we have a u right there. Our beginning was an x. So what do we have to do to get rid of this u? We got to plug back in what u equals. And so we have negative 1 over 1 plus x to the third. And there's a 3 multiplying to it. So you can just put the 3 on the outside, or you can actually distribute it into it. I'm being lazy right now, and I'm just going to leave it on the outside of it.